Hi everyone, we are going to start the session sooner. Good evening. A heartfelt welcome to all those who are joining today on behalf of our ECOR family. I'm UFO, and along with Ms. Amrita, we are here to anchor today's webinar. Our webinar, named as Fa-eira or Multifarious Diversified Snow, indicates the combination of diversified biological community in relation with the first manifestation of climate change, that is, the snow melt. This time was opted on the basis of the main theme of the webinar, that is, impact of climate change on biodiversity loss. We, the members of ECOR, hereby proudly present this international webinar conducted as a side event with Action for Climate Empowerment Youth Forum of YOUNGO, which is an official youth constituency of United Nations Framework Convention on Climate Change. YOUNGO ensures that the perspective of youth and future generations are taken into account while multilateral decisions are made on climate change related fields. It is a great privilege for us to conduct this program as a side event with YOUNGO. Now, for further proceedings, I would like to welcome Ms. Amrita to introduce the primary guest of today's event.
Thank you, Yusuf, for such a warm welcome. And as we move forward with this program, I would like to take this opportunity to introduce our distinguished guest and speaker for the session, Dr. Amy Louise Hall, one of the superwomen in real life, maneuvering more than 20 years being a profound zoologist and ecologist. Grabbing her undergraduate degree in zoology from the University of Wales, she advanced towards her master's in ecology and environmental management and PhD in environmental economics and management from the University of New York. Completing her Masters of Law in Environmental Law and Practice from De Montfort University, she took a strong stand against tree slaughtering in Jersey, stating, "It's time for true protection in Jersey." Amy is currently a program coordinator and senior research fellow for Jersey International Center for Advanced Studies, which is affiliated to the University of Exeter, the United Kingdom. Her dedication and love towards the conservation of animal resources made her the chair of Jersey Bat Group and of Zoology section of the Society Jersey Ace. She is also collaborating with various top universities and provide the geographic information system coverages and special analysis for a number of scientific papers using her expertise from field work carried out in United Kingdom, the Caribbean, and the South America. On behalf of ECOR Foundation and all the participants present here, I take this opportunity to invite Dr. Amy Lewis to address the gathering. Over to you, madam.
Thank you very much, and thank you again for inviting me to give this short presentation this afternoon, evening. So if I just share my screen now. So hopefully everybody can see that okay?
So yes, ma'am, it's perfect.
Thank you. So I'm going to go through a short talk today looking at climate change and biodiversity. And there'll be a few sort of case studies from around the globe, but being as I work for JICAS, we do sort of specialise on islands, so there'll be a few island-based studies here. Starting with a little bit of light-heartedness, I think it's true that every disaster movie in modern time has always started with a scientist being ignored. And this is something that we've seen very much when it comes to climate change and climate change emergencies, is that scientists have been talking about this for at least the last 40 to 50 years, and it's taking a long time for politicians and for governments to start to take the scientists more seriously and move forward with new laws and policies to try to minimise the impact that humans have on the climate of the planet. So we can see here sort of how climate change emergency declarations started from around the globe. And they started in Australia in 2016. There was the first one to actually decide there was a climate emergency, and there was a climate emergency plan that was put into place. And then when you start looking down the list, that you can see there on the 2nd of May 2019, that Jersey, where I'm based, actually declared a climate change emergency. But we'll come on to this a little bit later. There is an overemphasis on climate here and not enough on the impact of the rest of the planet that isn't on humans. So in Jersey, again, we have our climate change emergency, we have climate change risk policies. We're looking to see how climate change might actually lead to flooding, and therefore we need new shoreline management plans in place in the island, but also how to reduce our impact on the climate. Even though we're a very small island, we're only 9 miles wide by 5 miles across, we still have an impact, and everybody has to play their role in reducing carbon emissions globally. So what are the main concerns about climate change? Well, if we actually put climate change into a word cloud software from the internet, we can see the words here that appear. So this is actually looking at the Intergovernmental Panel report on climate change from online. And we can see that, you know, the overwhelming sort of words used are very human-based. They're anthropogenic. It's climate, it's warming, it's increasing seas, it's extremes for human, it's about change and impacts. There's very little here that is looking at biodiversity, and we'll come on to that later. Of course, we can't deny that climate change will not have a severe impact on all of the humans on this planet as well. 1 metre sea level rise will wipe out 15% of Pacific islands, and 190 million people will be living in areas projected to be below high water line by 2100, which is not a long time away, really. But there is a disparity here, because we do spend a lot of time talking about climate emergencies and not enough time looking at the biodiversity crisis part of this. And this is from a professional authority within the UK who very much are trying to lead this, and I see it's more sort of globally recognised now. And they started with, we declare that climate change and biodiversity crisis are inextricably linked and cannot be addressed in isolation, and need urgent and immediate action. This declaration calls on governments, businesses and individuals to act on both issues and for the use of nature-based solutions to adapt to and mitigate against climate change. We are committed to leading the way for our professionals to take urgent action to address this climate emergency and biodiversity crisis. And this is the way that more of us need to start thinking now. It's how the climate change that has been proven to be very much human-driven is impacting on the biodiversity around us. So along global biodiversity as a whole, we have seen unprecedented declines, not so much due to climate to now, but because most of the habitats are being lost. A lot of habitats being lost since 1900. We're losing a lot of species. We're losing a lot of biodiversity, and we're actually seeing that biodiversity is being driven by habitat loss, by habitat fragmentation, and habitat deterioration. So this is already ongoing, and this added level of climate on top of this is going to start speeding up the problems we are seeing when it comes to losing species worldwide. So when we look at biodiversity decline and the main sort of key drivers of it, and this is looking at the Global Assessment Report on Biodiversity and Ecosystem Services by IPBES, we're looking at changes in land and sea use, direct exploitations of organisms, climate change is in there, pollution and invasive species ingress into the areas where these particular biodiverse regions are. And again, a lot of this can be linked back to climate change. If we look at changes in land and sea use, this can be driven by the loss of certain sea fish or the loss of land and causing people to move into areas which are more biodiverse. We can see people exploiting organisms more because they're losing their natural food sources and moving on to rarer species. We see increases in pollution as we have more and more people in the world causing more pollution. And of course, the more people you have, the more invasive species we have that move around the planet freely. And this is causing all these different impacts upon biodiversity. So when we start looking at climate change itself, we can already see that there's been an impact on biodiversity by climate change. We've already seen a 1 degree rise in global average temperatures. And that's an important thing to take into account. A lot of the information that we see these days is we are trying to, looking at the conventions, which originally wanted to stop a upward movement of temperature by no more than 2 degrees above common day levels, and ideally no more than 1.5 degrees above common day levels under the Paris Agreement. But we've already seen a 1 degree rise in temperature over the last 100 years. And what is this doing to our species? Well, they're moving into cooler areas where they can. They're moving in upwardly altitudinal shift where they can. But of course, not all species can move quickly enough to outmaneuver climate change. And in some cases, what we're seeing is a change in the breeding and flowering dates of species and of plants, which means they end up with a mismatch between predator and prey species, resulting in some species having difficulties finding food. We're also seeing that entire ecosystems have been impacted due to heat waves and a lot of deaths of coral that have been seen in the last 2 years in the Indian Ocean. Even closer to home in Europe, we're starting to see heat waves, more forest fires, droughts, Mediterranean areas becoming drier. Some areas are getting significantly wetter and we're going to have floods, but not even winter floods. If you looked in the news today in Europe, you would have seen that there's been some torrential flooding in Germany over the last day that's actually led to the deaths of about 80 people. So summer flooding has been seen as well due to many more thunderstorms. And again, we're seeing many terrestrial and freshwater species are starting to shift due to the changes in temperatures, even within these regions. So JCAS mainly looks at islands, and so why are islands so impacted by climate? Well, if we look at the main sort of concerns from climate change, and we see that, as was mentioned by our host, that we have melting ice caps, and these are leading to sea level rises. And again, even when the water becomes warmer, it expands. So even existing water will actually be expanding, which will lead to higher tides worldwide. And the combination in these different things is causing flooding and erosion of low and coastal areas. And sea level rises are one of the most recognized threats. And of course, they have a huge impact on islands. And we've got to remember as well that when we start talking about how much sea level rises are looking to actually increase, and we're talking between 1.3 and 1.7 millimeters per year, and then it's been speeding up. You can see up to 3.6 millimeters a year. But it's important to understand that these rises are not uniform across the globe. So some areas are having very little sea rises, and some areas are having large regional sea rises, which are causing a huge problem. Here you can actually see the regional sea level rise trends from 1992 to 2012, with the highest figures obviously in red. So you can see where the areas are actually having the largest sea level rises, and some areas are actually having sea levels reduced slightly. And again, you can see here that obviously climate change can be very regional. So temperature changes between Mediterranean, Caribbean and Indian Ocean, and precipitation levels and sea level rises all vary around the globe. So all areas will have their own very specific problems. So whereas we might not see climate change impacting too much at home, other regions might be having huge problems when it comes to increased temperatures, increased precipitation and increased sea level rises. So it's important we actually act as a global community to try to reduce these particular problems worldwide. So due to islands having a limited area and being generally quite isolated, they already have exacerbated species loss, especially in tropical islands where they have a high number of endemic species. Sea level rises are seen to actually impact on some of these islands, certainly a lot of the low-level islands, and freshwater-dependent ecosystems within islands are seen to be very threatened. You can see here, as the slide says, that pine forest areas in Sugarloaf Keys in America declined from 88 to 30 hectares from 1935 to 1991 due to increased salination in the groundwater and vegetation transitioning to a more saline tolerant ecosystem such as mangroves. So you're seeing changes in ecosystems purely due to climate change. And of course, we need to then look at why are species on islands so sort of impacted by these different things, so be it climate and natural extinctions. And if we look over time, we can see what species groups are most likely to have gone extinct, where we see most of the losses. So we've seen a lot of losses of amphibians and mammals and birds since 1500, and you can see their declines in species survival since 1980 on the right-hand side of the screen there. And we are losing a lot of different species worldwide. But the important thing about islands is when we start looking at an island, you're more likely to have a species be in one of the more threatened categories of the IUCN red lists, purely because of the nature of the island. You have small populations, you have them within small areas. They're very vulnerable to extinction because you have not much extent of these particular species. And they are more impacted, therefore, by climate change, by the populations of people on those islands, and by just general biodiversity loss. So there are many drivers of climate change, as you can see here. So there's demographic and socio-economic, there's institutes and governments, and there's conflicts and academics. And then we have the direct drivers that cause different levels of impacts on terrestrial, freshwater and marine ecosystems. And again, here on the right of the screen, you can actually see here that natural ecosystems have declined by 47% on average relative to their earliest estimated states due to climate. And so islands themselves make up 5.3% of the Earth's land area, but contain 19% of the bird species, 17% of rodents, and 17% of flowering plants. So you've got these very biodiverse islands, you've got a lot of biodiversity within small areas. We also see a lot of extinction due to people moving into the islands, due to invasive species. Now they've got that extra climate change. So 45% of recent extinctions have been because of direct human activity. And again, if you look at the most biodiverse regions around the globe, they do tend to be sort of tropical areas or islands or highlands in some cases, but highlands can be considered islands in their own right. Again, looking at the map here, you can see the 25 global biodiversity hotspots around the world. And these have actually lost 70% or more of their primary vegetation. So, as I was saying before, island species are more impacted because they have small population size. They actually are in a small area. Therefore, it means that they end up being vulnerable, endangered, or critically endangered on the IUCN Red List much more often than non-island species. Also seeing increasing fragmentation. We're also seeing, obviously, that you have genetic problems with small populations on islands. So you have sort of the vortex, the extinction vortex going on, where you have a small population, where you have inbreeding, you lose genetic viability, you lose numbers of your population due to because they can't adapt to different niches. You have mortalities increases due to the genetic loss. So you have smaller populations, and that goes round again. And these are sorts of inbreeding, random drift effects and bottlenecks that you see in island populations, which actually makes them even more vulnerable to extinction. So how can species really try to shift to combat climate change? Well, some species, such as birds, can fly away if they can find somewhere else to go to, if their island is not isolated enough. And so you can see species shifting range, and this can be a horizontal shifting, so from one location to another. So it could be something moving from where we are down near France up to the UK to go to a colder climate. You can have species shifting altitudinally, again, sort of moving up a hill to a cooler environment, trying to almost chase the niche in which they live. But we also start seeing that pest species and invasive species are actually increasing in high latitude in islands as well. So these species, these native species, are moving into areas and coming into contact with invasive species, and these are causing extra problems as well. So again, if we start looking at incidental ways that species can also be impacted, if we look at the Mauritius kestrel, and what we've seen here is we've known that they've been reducing in number over a number of years, and a lot of times it's been blamed on vegetation control, so DDT. And this is true, there was had a lot of poisoning of the kestrels over time. But a recent study has also shown that in the last 50 years, changing rainfall conditions have resulted in reproductive success mismatch between the time of breeding and the peak food abundance for this species. So as well as having habitat loss, having invasive species on the island, they're also having problems with their breeding success due to climate. I'm going to run through a few sort of scary statistics from WWF. So this is looking at the implications for biodiversity and global warming. And what we can see is if we see 2 degrees warming, then 1 ice-free Arctic every sort of 10 years. 1.5 degrees warming is every 1 ice-free Arctic summer every 100 years. So that half a degree difference is making a huge impact there. From sort of 1.5 degrees, we're looking at coral reefs, we're looking at a decline of 70 to 90% of coral reefs. If we go to that 2 degrees, we're then losing up to 100% of coral reefs. And that would be a travesty to actually lose that. We're looking at, obviously, alpine species as well. So they're moving up mountain slopes, and at 1.5 degrees, they can move up mountain slopes and try to survive. But again, looking at 2 degrees, then these species are actually starting to run out of mountain height and habitat to actually be able to combat climate change. At 1.5 degrees, we're going to lose 6% of insects, 4% of vertebrates, and 8% of plants. And again, at 2 degrees, you can see the difference there, 18%, 8%, 16%. So half a degree makes a huge amount of difference in these scenarios. And if you start looking at the 4 degree, well, I think at the moment we're on a 3.6 degree increase if we do nothing or continue as we are at the moment. Again, this is looking at it, but also looking at a human impact as well. So at 2 degrees, 49 million people are impacted by sea level rise, as opposed to 46 million at 1.5 degrees. At 2 degrees, 410 million residents are exposed to severe drought by 2100, as opposed to 350 million at 1.5 degrees. At 2 degrees, we've got 2.7 billion exposed to severe heat waves every 5 years. And again, you can see it's still scary figures, 1 billion at 1.5 degrees. So we really do need to try to keep those actual temperature rises down as much as possible, both for humans and for species. And again, this is just sort of consolidating those previous slides. Coral reefs are a huge concern, and between sea level warming, sea level rises, changes in storm patterns, changes in precipitation, altered ocean effects and ocean acidification, they are massively impacted upon. Everything to do with climate change impacts on our oceans, impacts on our coral reefs, and therefore impacts on the fish that live within those, and at the end will impact on the humans who use these areas for both leisure, tourism, and for food. So we need to be very, very interested in what's going on with our climate. And we're starting to see more political will, and we're starting to see more potential solutions. But it's still taking a long time between when we learn about climate change and when governments are starting to take action to address that through policies, through controls. And whereas everybody seems to understand the consequences, really people need to start taking them a little bit more seriously when you start looking at the modelling and the temperature rises that we are looking to see over the next 100 years. So just running through some of the island biodiversity and climate change information from the Convention on Biological Diversity, so going back to sort of some of those main law conventions, we can see that 75% of animal species and 90% of bird species that have become extinct since the 17th century have been on islands, and 23% of those are currently considered endangered, which outstrips the rest of the world. And we can see that obviously island developing states are also vulnerable to climate change because of socio-political and economic characteristics. So we've got the climate, we've got the projected sea level rises and the potential increase in the frequency of storms. And then what we're going to do when we end up with climate change refugees. At the moment, we see a lot of people being refugees because of wars or because of conflicts. But we are going to start seeing those people who are losing their Pacific Island homes, those many millions of people whose homes will go underwater, who will need to find somewhere new to live. Now, some Pacific Islands have started to actually build new islands at a higher level to try to move their population to when their homelands go underwater. But not every island chain is able to do that. We actually can see the differences in the polar areas as well. And the polar areas are actually home to a large number of plants and animals which are only found there. And they can't possibly move to areas that are colder because those are the coldest areas that we have. So we're going to start seeing less sea ice, and it might disappear altogether. And we're going to see reductions in the sea ice, which are going to lead to increased sea levels. We're going to see polar bears actually having problems and more problems in hunting. And we're going to see a decline in emperor penguin populations as well down in the Antarctic. And what are all these species going to do? It's not as though that they can easily migrate to a cooler area, to one that is also going to be useful for them. It's not as though they can use their genetic diversity to breed quick enough to actually cope with the levels of climate change. It's just happening too fast for them. And in some areas of the Arctic and of North America, you are starting to see polar bears move into towns. You're starting to see them hybridize with brown bears. And maybe that's the only way that their genetics can survive, is to actually form a new hybrid species with a different bear species. We're also seeing forests being impacted by climate change. So we know that as much as 2/3 of all known terrestrial species are found within forested areas. And for the last 8,000 years, 45% of the original forest cover has been converted. Most of it has been cleared during the last century. And I know some countries are planting trees at a massive amount of, massive rate. And some of those are India and China, who are actually reforesting quite vast areas. But forests are actually very vulnerable to climate change as well. Changes in temperature, changes in precipitation can actually impact on the forest growth. And you can actually see that that has knock-on impacts for the functioning of the ecosystem, for the ecosystem services. So what's going to happen if we start losing our forests due to climate change? Well, some of our largest primates live in these forests, and we're quite likely to lose them. 9% of all known tree species have some risk of extinction, and 80% of all the carbon stored in terrestrial vegetation is found in these forests. So we can't let that happen. We need to preserve these woodland areas. And coming towards the end now, we start looking at the marine and coastal biodiversity. And oceans cover 70% of the Earth's surface and provide most diverse and productive ecosystems, including mangroves, coral reefs, and seagrasses. And as it says here, coral reefs are sometimes called the tropical rainforests of the ocean and provide livelihoods for 100 million people and actually have a net worth, a net benefit of $30 billion. Although reefs are only 0.2% of the seafloor, they've got 25% of the marine species. Now, if we lose all of those reefs, what's going to happen to that fish? I mean, how's that going to work for us when we use those areas to fish in? And again, with inland waters as well, we're also seeing problems when it comes to climate change and biodiversity. 20% of the world's freshwater fish have become extinct or threatened with extinction in the recent decades. And wetlands, as well as rainforests and also oceans, are the primary carbon sequestration mechanism, especially in peatlands of the boreal regions. So we're starting to see some of these areas that are under permafrost, where that particular frost is melting, and all of the methane that's stored in these areas, as well as carbon, has been released up the atmosphere. So that's a huge problem as well. And unfortunately, we've started to see people starting to plant trees in inappropriate places to try to counter the effects of climate change, but not understanding that peatlands are actually very important too. The last thing you want to do is plough a peatland and plant trees. It has unintended consequences. So what can be done about all of this? Well, human consumption of fossil fuels is the primary cause of the greenhouse gas emissions. So we need to start looking to shift to low carbon alternatives. That is very essential. We also need to start looking at nature-based solutions in a way of mitigating against climate change. And that could be planting mangroves, planting woodlands. All of these things would make a large difference. And most importantly, every government, every business, and every organisation has to play a role in reducing greenhouse gas emissions. Going back to Jersey, we're a very small island. We don't produce much carbon, but we still have a carbon neutrality strategy to try to make the island carbon neutral by 2030. And we think it's very important that we play our role as a global citizen to try to reduce even the small impacts that we are having locally on the world as a whole. So thank you very much.
Thank you so much, Amy, for the wonderful talk. Participants are now requested to type in their doubts or questions, if any, in the chat box. Yeah, so madam, there is a question from Pooja. Can you explain about artificial coral reef making? Is it a useful method for preventing ocean acidification problems or other climate change related issues? Ma'am, can you throw some light on this?
Yeah, sure. So yes, we can make artificial coral reefs. We can try to build them in areas whereby the sea level rises won't impact them as much, or we can try translocating corals from one area to another. Some of this is successful, but it's an awful lot of work when you see people trying to plant up new coral reefs or create new coral reefs. And yes, we can save some in this way, but it really is just the not to pun too much, but it's the tip of the iceberg. We will end up losing still 99% of our coral reefs, even if we try to translocate ones to new regions. So it is worthwhile, but it's not going to significantly impact upon the ocean acidification, or it's not going to cause, it's not going to solve our problems, and it will be a large cost to actually do it.
Yeah, thank you so much, ma'am. Pooja, hope that your query is being solved.
Any other questions?
Yeah, ma'am. There is another question from Maha. Why isn't developed countries putting much efforts in reforestation programs?
It's a very good question, to be honest with you. What you tend to find is that a lot of developed countries have deforested historically. So a lot of that tree loss happened from sort of like the 1500s up to the 1900s. And a lot of that land has been turned into agriculture. And some developed countries, such as France and Germany, do have around about 25 to 30% forest cover across their countries. But places like the United Kingdom have only got about 11 or 12% forest cover. Now, there are plans within the UK to plant trees to try to get the forest cover up to more like 20% within the next 50 years. So they are trying to reforest areas. But what they're also doing is actually sending money through carbon offsetting to plant trees in other countries as well. So there are efforts going in to do that, as well as sort of restoring their own land, but also helping to restore forests in other countries as well. But it's a good question.
Yeah, thank you so much, madam. So there is one last question from Venumani. So how effective are climate change induced vulnerabilities studies in policy making and ground level implementation? Ma'am, please.
Yes, it varies around the globe as well. There's a really good online simulation package you can use called En-ROADS. So that's EN space then roads, which is done by MIT in the United States. And you can actually go online and play around with it to see what different changes countries could make to try to reduce carbon levels in the atmosphere and methane levels. So it gives you an idea of what policies people need to put into place and what people need to do to try to reduce those emissions, but also to offset by reforestation. And there is a lot that needs to be done. If you play with that simulator, you'll notice that you will have to sort of really start taxing fossil fuels, start hugely subsidizing carbon neutral alternatives, stop cutting trees down, doing a lot of reforestation, and sort of trying to look at economic growth as well, trying to make sure that all of this works together and becomes an effective tool. Now, how much countries are willing to do that, because obviously it impacts on their own cost of livings and their own sort of populations, will be an interesting factor. We all need to do something. We all need to understand that our standard of living will decrease if we need to save the planet.
Yeah, thank you so much, madam. So due to time constraints, we'll be happy to respond to the other questions as well by mail. So let's move ahead. So now I would like to render my thanks on behalf of ECOR Foundation and YOUNGO, our side event partner. Here, I wish to express my sincere heartfelt gratitude to the real superwoman, Dr. Amy Louise Hall, the program coordinator and senior research fellow of Jersey International Center for Advanced Studies, the United Kingdom. This talk has created an apt insight among us on the relevance of environmental and climatic laws in the current scenario. For the protection of environment, there is a set of regarding regimes now strongly influenced by environmental legal principles focusing on the management of specific natural resources such as forests, minerals, fisheries, etc. All these legal principles should be followed by each and every one of us to conserve our environment. Once more, thank you, ma'am, for this mind-blowing session and for sparing your valuable time and precious knowledge for our benefit. Thank you, madam. Continuing our program, we can now move to our second session of the day. Now, I would like to request Miss UFO to introduce our speaker. UFO, please.
Thank you, Amrita. Now we have among us Professor Muthukumar Muthuchami, the Dean at School of Earth Science Systems and HOD of Department of Environmental Science, Central University of Kerala, India. Sir is a young scientist awardee specialized in various fields such as water and wastewater treatment, sludge reduction process, biodiversity ecology, hydrology linkages, ecological modeling, climate change and adaptation studies, renewable energy, microbial fuel cells, and environmental impact assessment. Presently, Sir's team is researching the areas of climate change and adaptation studies in collaboration with the Institute of Bioecosciences, MD USA, for the Western Ghats biodiversity conservation and the production of energy from solar and wind in collaboration with Sokoto Energy Center, Usmanu Danfodio University, Nigeria. Apart from that, preparation of catalysts from rare earth metals for electro-oxidation studies and collaborating with the University of Concepcion, Chile, Latin America, National Metallurgical Laboratory belonging to CSIR in Chennai, India, and National Institute of Interdisciplinary Science and Technology, Thiruvananthapuram, India. He has also received major projects from various funding agencies such as DRDO, UGC, DST, BRNS, etc. It's a privilege to have Muthukumar sir among us today. Welcome, sir.
Thank you. I think you have to enable me to present my slides, please.
Yes, sir.
Yeah.
Sir, you can directly try presenting, sir, once.
Sorry?
You can directly present it.
Is it visible now?
No, sir.
No, that's what I said.
Yes.
Yeah, enable because it's hiding there.
Just a minute, sir.
Yeah, I'm not able to. Yeah, I think now it's okay.
It's visible, sir. Thank you.
Yeah,
Sir.
okay. Thank you. Thank you. Thank you for really. I have to thank Mr. Jesno. Okay, he's the one who was initiated. Okay, me to share the experiences what I gained from the past 8 years, where I am working on the climate change studies modeling. Actually, I'm a specialist on water and wastewater treatment, and for the past 25 years, I'm working on that field. And recently, because of some interest, I moved to the climate change modeling, especially on the biodiversity conservation. Okay, so I think Dr. Ami has clearly explained about the climate change and its important, okay, or the crisis, okay, or biodiversity and aspect, right? So here I'm going to discuss my research area and biodiversity conservation, how it is going to affect the diversity of our Western Ghats. Okay, so before going to that, when we are talking about climate change, right, and even every day in life, people are talking about climate change, right? For example, if there is a heavy downpouring, rain is there, okay, and immediately we will say because of climate change, there is a huge amount of rain is falling, or there is no, or we can say the monsoon is failed. Immediately we will say it's a climate change because of climate change, right? whatever it is, simply we are correlating with the climate change. So what is climate change actually, right? According to the UNFCCC, it defines the climate change, the change of climate, which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere, and which is in addition to natural climate variability observed over comparable periods. That's what it says. Even according to the IPCC, it defines the climate change as a change in the state of climate that can be identified by changes in the mean and or variability of its properties, and that persist for an extended period, okay, typically the decades or longer. Because normally when we say a climate change, we have to compare, right, in the past and the present. And that's why we can say whether the climate has been changed or not. Okay. So similarly, normally they are comparing, okay, for past periods, and they are saying how it is. Okay. Since my topic is on the conservation of biodiversity, before going to the conservation studies, first I would like to know what is diversity, what is biodiversity, right? So biodiversity refers to the numbers, variety, and variability of living organism and the ecosystem. That's what it says. Okay, which includes whether it's a terrestrial organism, marine organism, or in aquatic organisms. And also it covers the diversity within the species, between the species, as well as the variation among the ecosystems. So what are the factors determining the diversity of the species? Mainly because of the habitat stress. Okay, this is one of the main reasons. Or geographical isolation, all right? Or dominance by one species. For example, if one species is dominated in the particular places or area, right, there is a stress is created. Automatically, there is possibility of diversity. Or the availability of ecological niches, right? For example, if a species, any species, you can take it as when it is interact with the biotic or abiotic components, right? It is if it is suitable, normally it flourish, right? And also the edge effect. Edge effect is nothing but two habitats are joined together. For example, there is a grassland ecosystem or forest land ecosystem. Okay, when joined together, okay, the edges, two boundary, okay, the two boundaries are meeting together. There is a possibility of the diversity, okay, and the geological history, right? What are the important role of the biodiversity? Because biodiversity, when you say it's a very important role as ecological role, right? Because in the atmosphere, every species has its own role, right? So, am I audible?
Yes,
Hello?
sir, you're audible.
Yes, sir.
Yeah, okay. I'm sorry. Okay. So the ecological role, I said, every species has an individual role, all right, in the ecosystem. Okay, and each function is integrated or integral part of the regulating the species balance, or what you can say, the species diversity or the species health. Okay, so ecological role is very, very important, and economy role, like food, like agro, what you can say, biodiversity, where we are getting the foods, or goods like timber, furnitures, okay, what we are getting it, paper or medicine, okay, where we are getting, okay, so it plays an important role on economy also, and also the scientific role, right? Like the biotechnology or genetic engineering, they are making new genes, and with the help of the genes, they are developing a new crop or medicine, whatever it is, they're doing it, right? And also the scientists, they are getting some clue from the species evolution, how it is evolved and how it is evolving. Okay, from this species only they are getting it. Okay, so it is very, very important. Biodiversity is important. Right. So when it comes to India, right? Biodiversity in one of the beautiful country, I can say, and we have all kind of ecosystems are here, right? When you talk about Himalayas, okay, hilly regions, okay, right, or ice, high ranges, okay, different diversities there. Or take Western Ghats, okay, here is a different diversity. Or you can go to a desert, right? There also a different diversity. Or if you can, we have one of the largest mangroves in Kolkata, right, West Bengal. And also we have the Ramsar site, it's called Sinka Lake in Odisha, okay, largest lake, right? So very beautiful, or the different types of diversity in India we are among it. And unfortunately, the biodiversity is getting lost, okay. Why? According to the Convention about the life on Earth, what it says, at least 40% of the world's economy and 80% of the needs of the poor are derived from the biological resources. That's what it says. And the richer the diversity of life, the greater the opportunity for medical discoveries, economic development, and adaptive responses to such a new challenges as a climate change. Right? So, because of this reason, there's a possibility of habitat loss and degradation, habitat fragmentation. Okay, there is the main reason for the decreasing the diversity. So, according to the British scientist Norman Mayes, who has coined the term biodiversity hotspot in the year 1988. Okay, later the Conservation International has adopted his theory, and based on that, they have been classified many of the places hotspots. Okay, so the hotspot, what he is saying, based on the biogeographic region, by both the endemism and habitat loss. There are two criteria. So when you wanted to say some places, okay, or some of the area is a hotspot, okay, according to his Mayes, what he has given two criteria, important criteria, yes. Okay, the Conservation International has followed, right? There are two criteria. The first criteria, what it says, it must contain at least 1,500 species of vascular plants as an endemic. Okay, it should be present only in the particular regions. Okay, and it has to have lost at least 70% of its original habitat. It has to lose its original habitat, 70%. So if that is the case, they call it as what you can say, the hotspot, right? So based on this criteria, okay, and in 1999, it was classified and they made it as a 25 hotspot, and now it is a 36 hotspot in the world. Okay, and this hotspot covers 2.4% of Earth land surface. Okay, but, approximately more than 50% of the world plant species are present in the hotspot regions, and 42% of all terrestrial vertebrate species are endemic to the 36 biodiversity hotspots. Okay, then in Africa there are 8 hotspots located, right? Asia Pacific there are 14 hotspots are located, and Europe and Central Asia it has 4 hotspots. North and Southern America has 4 hotspots, and also South America has 5 hotspot regions. Okay, throughout the world. And come to India, right? And we have 4 hotspots. Okay, one is the Himalaya. I think everyone knows that, right? It starts from Pakistan, Tibet, Nepal, Bhutan, China, and also it goes to Myanmar. Okay. The another hotspot is called Indo-Burma, right? Because it starts from northeastern side. Okay, from Assam, Myanmar, Thailand, Vietnam, Laos, Cambodia, and southern China. Okay, it goes like this. And also Sundalands includes Nicobar Islands. Okay, from Indonesia, Malaysia, Singapore, Brunei, Philippines. Okay, it also covers. And Western Ghats and Sri Lanka. Okay, complete Western Ghats and includes in with the Sri Lanka. Okay, right. Western Ghats, when you talk about Western Ghats, since our main focus on Western Ghats, it is one of the majestic mountains. Okay, everyone knows that. Okay, when you come to India, right? one of the seven largest mountain in India. Right? It has the range, okay, from approximately 1,600 kilometers. It starts from Tapti River to the Kanyakumari. Okay, it is, and also it travels 6 states. Okay, it covers, right, and because of the geology and geomorphology, coupled with the high rainfall in this region. Okay, because of that reasons, here the landscapes, everything are very diversified, and also the Western Ghats. We everyone knows that it is one of the hottest hotspot in the world. Okay, there are 8 hottest hotspots. In which one? Okay, why this kind of rich in diversity in Western Ghats? Right, because the theory what he says Gondwana land was in earlier days. Okay, there was a single land mass. Then because of the splitting or plate movement, okay, the continent has been formed and splitted. Okay, so our India. Okay, according to the Gondwana theory, okay, what it says separately it come out. Okay, that's what it says. The Indian landmass being pushed to the Eurasia. Okay, it is pushing because people are saying that the Himalayan hills are growing. Right, Everest is growing. It's what it says. Because Everest mountain, something they'll say. Okay, because our land, okay, our plate is completely hitting on the Eurasia. Okay, it's pushing. That is the reason it is slowly growing. Okay, and because the what to say the Western Ghats, the other areas because water, right? It's a mountain region because you cannot cross over here, right? Because of that, the huge amount are very rich in biodiversity, especially in the Western Ghats region. Okay, right. So why it is hottest hotspot? Because it's a wide range of forest types. Okay, because you can see from a tropical wet green evergreen forest to the grasslands. All the different types of forests you can see in the Western Ghats. Around approximately there are 5,588 species of flowering plants with a high degree of endemism. Okay, only the endemic plants alone is there 5,000. Right? And very rich in fauna with endemism ranging from 11 to 78% among the different groups. You can find it. Okay, according to the high-level Western Ghats Committee, what it reports that 2014, okay, it says approximately 140 mammal species are present, 260 reptiles, and even 510 species of fauna, and 180 avian species represent. Okay, and also they say every year they're discovering a new flora. Okay, and there are around 2,253 species are endemic to India, in which 1,273 species are exclusively confined in this Western Ghats. Okay, approximately I said 140 mammal species have been recorded in this area. Some of these I think probably you might be knowing it. Right, this vine-tailed macaw. Okay, it's one of the endangered species present only in this area, especially in Silent Valley. Okay, or in Tamil Nadu Valpara region, you may find it. Okay, this vine-tailed macaw, or this Nilgiri marten. Okay, Maranai, some you call it as. Okay, this is it come under vulnerable species. It is found only in the Nilgiri regions. Okay, the Nilgiri Thor. Okay, this is also an endangered species only found in Nilgiri regions, especially in the Arabiculum area or Parai and Arabiculum region. Okay, there you can find animal tiger, so you can find it in this variety. And this Malabar large spotted civet. Okay, this is also coming under critically endangered. Okay, you can spot in even the Coorg regions where you can find these species. Okay. And also the Malabar pit viper. Okay, even though it is more in number, but it is endemic to the Western Ghats. Okay. And also it was recorded 510 bird species known for the Western Ghats. Around 22 species are occurred nowhere else in the world. That's what it has been reported. Okay, and like Malabar grey hornbill, right? It is endemic, and also you may not find it anywhere in the world. It is coming under vulnerable. And the Nilgiri woodbridgian, Okay, this is also is coming under vulnerable species. You can find it only in the Nilgiri regions, and this is also the Nilgiri laughing thrush. Okay, it is coming under endangered category. All right, you can find it only in the Nilgiri regions. Okay, then some of the other species like blue-winged parakeet or black and orange flycatcher or rufous babbler, okay, or grey-headed bulbul, right? All are located or endemic to the Western Ghats only. Okay. Um, there are the flowering plants. When you come to flowering plants, as I said already, 5,588 plant species are there in Western Ghats. Out of 7,402 species are native of Western Ghats. Okay, and few just I wanted to say this is a Auto-1G. Okay, because it has some medicinal properties, right? It is coming under vulnerable. Okay, or near 1G, they used to call it as the local people, right? Our Chinnavam species, Shanda Maram, it is called. It is also coming under endangered. It has many medicinal properties. And also this Malabarica, Mystica Malabarica, or Cotujarica, they used to call it as. Okay, it has great medicinal properties, and also is coming under vulnerable. Okay, and this Vadam Kollimaram. Okay, this is also coming under critically endangered species. Okay, but since it has a very high medicinal values, and unfortunately it's going to critically endangered listed. And even the Mahilan Vilanga also, this species also is coming under critically endangered species. Okay. And even Kundridakam, okay, this species of plant is also is coming under critically endangered species. Certainly, it has huge medicinal properties. Okay, and this Angeli or Lavo, call it as in the local. Okay, this is also one of the endemic species which is present only in Western Ghats. Okay, and this is Kartukurumulagu. Okay, this is also one of the important the medicine property it has for the post compliance. Normally they used to have it. Okay, this is also coming under endangered species, and this is Nanari. Okay, probably this good for constipation and acidity. People are using it. Okay, yes. Also coming under vulnerable, and this how to say the Sarcosa sorghum used to call it as. Okay, this is also having a good medicinal properties. Okay, but coming under vulnerable. There are many numbers. Just I wanted to show you. That's why I given. Okay, so as I told you, the diversity. Okay, different kind of ecosystem. You can see it from evergreen. As I said, evergreen forest, semi-evergreen forest is there, moist deciduous forest is there, tri-deciduous, teak, bamboo, mangrove, sholas, riverines, groves, comes, all you can see, okay, including the settlement in the Western Ghats regions, okay, and also it is a life supporting and biodiversity rich ecosystem, okay, it gives the supplies water, especially, okay, water resources for the 50 million people belonging to the 6 states of the country. Very important for the monsoon. Okay, right. So coming to this impact of climate change. Okay, how the climate change has impacted on the diversity of Western Ghats. Right. So in our research, okay, our team is we are working on the past 7 years. We are working on the providing the strategies or adaptation, okay, strategies to conserve the endangered or critically endangered species. That's what we are doing it. Okay, so we are studying the species distribution. Okay, how this climate has impacted on the distribution of the particular species. Okay, but we are selecting only the red listed category, like endangered, critically endangered, or even what you can say, the vulnerable species we are selecting, and we are studying, doing a modeling, okay, with the help of the accent, and we are predicting the distribution in future. Okay, currently how it is distributed in 2050, how it's going to distribute, or how it is going to affect our shrinking or to enhancing, or the 2070 also. Okay, these are the things which we are working on at that, right? Especially to predict the pattern changes in the plant biodiversity, how it is going to disturb the climate change. Okay, impacts or on the plant biodiversity, and also we are identifying the vulnerable areas, the packet, which area or which packet, okay, it is getting worst, so that okay, how we can provide the adaptation strategies or conservation strategies to retrieve the area. And also we are calculating the endemism in the vulnerable areas, and we are also developing the database with a specific adaptation strategies. Okay, this our team is working on it, our team members, and normally what we are doing it, we are collecting the data, downloading the data from the with the help of the to what to say, the remote sensing tools, right, from the USGS Explorer, and especially the Landsat find Landsat 8 data. So we are downloading it, and we are analyzing the how the temperature, whether it is the land surface temperature is increased or not, how the vegetation changed with the help of the spectral analysis which we are doing, and also we are studying the topography or elevation model or control model, okay, how it locates or looks, okay, how it is impact when we are doing it. Okay, for the study, I think we are using on the Maxent or QGIS, ArcGIS, DiverGIS, or Studio, Excel, okay, all the tools which we are using for the our modeling studies. Okay, so now for the assessment of land surface temperature, when you talk about the increasing temperature, all right, so whether it is really is what increased or not to study. We have been collecting the data from the Landsat data. We are satellite collecting and downloading, and we are analyzing with the help of the RGIS tools. Okay, and clearly it's mentioned that like there is a anomaly area during the year 1993. Okay, see the temperature, minimum temperature 6.98 to 34.43 degrees Celsius maximum. Right, but in the year 2018, it got increased. The minimum temperature has been increased to 10.6 to 37.98. Okay, it is clearly indicates that there is a possibility of the land increasing the land surface temperature. Even this is the Geographical National Park where we have done some of the work on it. Okay, it also clearly mentioned that 7.48 is a minimum degree Celsius temperature. Would increase to 13.63 degrees in the year 2018. Right. This is also indicates. Okay. This is the Bandipo National Park. Okay. Because since we are concentrating more on this reserve forest area. Okay. In the southern Western Ghats. Right. This also clearly indicates that there is increasing on the temperature even for Paramikulam Tiger Reserve. Right. This also indicates from 15.91 to 16.5 degrees Celsius and 33.69 to 33. Okay, because it's fortunately here some of the conservation measures they are introduced, and it is working very well. That is the reason here also the temperature is little slightly controlled, but however you can see the vegetation also it got improved compared with the other reserve forest. Okay, this is also the land surface temperature of the Chinar Wildlife Sanctuary. Okay, here also clearly indicates that from the data from 1990 to 2020, it does indicate there is a possibility of huge amount of increasing the temperature from 9.562 degrees Celsius to 17.48 degrees Celsius. Okay, and 35.26. Okay, the minimum temperature got drastically increased in this area. Okay, and also the Chimney Wildlife Sanctuary also from 1990 to 2020 is clearly indicates that there is a possibility of increasing the land surface temperature. It is clearly indicates that there is a temperature. Okay, because of the increasing temperature, the possibility of forest fires. Okay, the frequency of the forest fires has been got increased. Right, from 2018 to 2020, the data what we got it, and we have analyzed and mapped. Okay, which are the area is mostly risk for mapping the risk zone. Okay, just for the past occurrences we have been mapped. Okay, it clearly indicates that there's a possibility because of the high rise in temperature. Okay, right, and also we have analyzed the temperature trend analysis, especially in the Chimney Wildlife Sanctuary. We have collected more than 100 years data, 119 years data we have collected and we have plotted. Okay, it is clearly indicates that the average annual monthly average temperature is getting increased every year. Okay, it's approximately 0.5 to 1 degree Celsius. Clearly, it indicates that it has increased. Okay, so the study is clearly proved that there is a possibility of increasing temperature and surface temperature. Okay, it has been proved. And second, we have studied the vegetation index. Okay, because vegetation index means it shows that the health of the ecosystem, okay, or the forest, or you can say the greenness of the forest area. Okay, the NDVI, the normalized different vegetation index, has been used for many applications, especially for the forest cover change detection, or crop monitoring, or drought monitoring, or land degradation assessment, vegetation biomass estimation, or land use changes. Okay, these are the main applications. They are using it. Why? Because it has a higher resolutions. Okay, the value what we are getting it we can predict, and the coverage area is a huge area you can easily cover, and also, as I said, the accuracy of the result is very high. Okay, and so it is easily the representation, graphical representation, easily the what is it, the decision makers. Okay, you can take a decision easily based on the graphical representation, and represents seasonal or periodical changes. It clearly indicates okay, and also high oxidation frequency. Earlier, what instead of NDVA, they used to call it as RVA. Okay, it is called ratio vegetation index. Okay, and simply they calculated based on the red light divided by the near air rays radiation. Okay, simply they calculated. Later they changed it into different vegetation index DVI, and now the year 1974 onwards, we are using the word normalized different vegetation index. Okay, and they calculated based on the formula NIR minus red divided by NIR percent. Okay, so there we are getting the data normally. Okay, the NDVA can be performed using the satellite data sets because we are downloading from the GIS platform. Okay, and the preferences of satellite data depends on the place and time of analysis, the purpose of the application, or adequate spatial resolution to address it. Normally, the resolution is very important. For NDVA, we used to take us 30 meter resolutions. Right, especially for the LST, normally we used to take as 100 meter resolution, but whereas for the vegetation index, okay, we used to take 30 meter resolution. So even you can go for further, but for that you have to pay for it. Okay, there are many satellite data we can download it, like Sentinel or QuickBird, WorldView, okay, Novas or Modi, Spot. Many you can download it from it. Satellite data you can available. But if you need a higher resolution, certainly you may have to pay a huge amount. Okay, so normally we are downloading from the Landsat data. Okay, especially when we download it. Okay, the range bandwidth like 3 and 4. If it is I'm using Landsat data 5, we are using the band 4 and band 3. Okay, right. So normally the way how we are doing it is we develop the shape file, and then we are from the USGS we download the data. Okay, and from there we are analyzing only the band 4 and 5 for Landsat data, or 4 and 3 for the Landsat 5 data, because for NDVA normally we used to use only 4 and 5, but whereas in the case of land surface temperature, we used to have 10 and 11. Okay, 10 and 11 band we used to do it. Right. Okay. So how the measurements, how we are measuring it? Okay, because normally the leaf will reflect. Okay, reflect the radiation in the form of NIR, near IR. Okay, radiations. Right. If it is a healthy leaf, the radiation NIR is very high. Okay, compared with the red light. But whereas if it's a stress relief, okay, almost very less in number NIR and also red light also. But whereas a dead leaf, it gives almost similar values, red and NIR. Okay, so the ranges, okay, from -1 to +1 normally it gets from. Okay, vegetation index will be represented from -1 to +1. Okay, so if -1 means where there is a possibility of water. Okay, water may center. Okay, -0.1 to 0.1 is a barren rock, or this is what we are interpreting. Okay, based on analysis when we get the readings. Okay, we used to normally analyze or interpret 0.2 to 0.4 it is a shrub or grassland. 0.4 to 0.9 is a dense forest. Okay, so based on that, okay, what we have done, we have analyzed the vegetation index in the area of Animal Tiger Reserve during the year 1993 and 2018, and we compared. Okay, so you see the vegetation index, it was 0.68. Okay, in the year 1993, but whereas in the year 2018 it comes down to 0.44. Okay, that means vegetation got decreased. Even for the Geographical National Park, 0.45 minus 0.044, sorry, 582 0.026. It also comes down. Okay, it is almost the vegetation greenness got decreased. Even for the Bandipur National Park also, okay, it was noticed there is a drastic decrease in the vegetation index. Even for the chimney wildlife, okay, when we compare with 1992 to 2000 data, right, there is a possibility. See this, the high values we got it in 1992, it was 0.75, but whereas in the year 2020, it comes down to 0.53. Okay, it is quite decreases. Even for the Chinnar Wildlife Sanctuary also, it has been clearly indicates that there is a decrease in the vegetation index. That means even Paramiculam also, but Paramiculam, as I said, okay, there's a fortunate that there is a few conservation measurement they have taken, they introduced. Okay, because of that, there's a possibility of what I can say, the greenness has been what increased. See this 0.726 to 0.83 it got increased. Okay, because of the measurement what they have taken. Okay, so this is overall of the southern Western Ghats. So what we have studied from 2011 to 2018 data is that there is a decrease in vegetation index overall. Okay, that's what it says. So what we are doing it, as I said, we want to predict the future distribution. That is very, very important. Whether the particular species will be there for another 100 years or 200 years, whether it will be exist in the forest. Okay, this is what we wanted to know. So that is why we are doing the modeling. Okay, it's called maximum modeling or future distribution modeling or ecological modeling. We used to call it as. Okay, so for to do the modeling, what we do, we collect the data from the Valkilling or data basin. Okay, for 19 bioclimatic variables are there. We download the data, and also we download the altitude aspect or slope data and extract it, and with the help of the UGS, okay, we will analyze and we will use for max center. And also we used to visit the field and collect the coordinates, okay, where the particular species is located. And also, if not possible, we collect the data from the herbarium, okay, or from the what you call the global biodiversity information form data. There also we go download it, okay, and we are processing it for the accent modeling. Okay, from this output, again we are analyzing with the help of the OGIS or the GIS, and we are finding out the distribution, how the particular species is distributed. Okay, how in future, how is going to, what kind of effect is going to happen, right? So normally I said the 2050 or 2070, okay, based on the representative concentration pathway, there are four different different concentration pathway has been given, like 2.6 or 4.5, 6 like 0.5. Okay, so based on that we are doing it, right? So this is what it says, different representative concentration pathway. What it says, if it is a 2.6, there is a possibility of increasing temperature by 0.9 to 2.3 degrees Celsius. If suppose, for example, if it is the representative concentration pathway is 4.5, there is a possibility of increasing temperature from 1.7 to 3.2 degrees Celsius. Okay, or RCP 6 to 3 degrees Celsius, or RCP 8.5 to 3.5 to 5.4 degrees Celsius. Okay, but our Paris Convention is working on with less than 2 degrees Celsius. Okay, even for the what to say, the recent climate change meetings, conferences clearly indicates that we have to stop less than 2 degrees Celsius. That's what we are working on it. Okay, right. So just I want to show you one model how the species has been distributed. For example, this is the plant, a very huge tree. Okay, it's a Ficus fedomi. Right, it is 25 meter tall, very huge. Okay, and the plant, it is normally called as an endemic keystone species. Right, it's just Okay, so based on the coordinates on the data available for the last 30 to 50 years of what we have collected, and we have been mapped. Okay, so see this. Okay, this is the current scenario, and the red colors clearly indicates that it is very high suitable. Okay, and the particular species. Okay, these are the area is highly suitable for its habitat. Okay, but when you do a modeling in the year 2050, okay, if the RCP concentration is a 2.6, okay, unfortunately, the very high suitable habitat has been got decreased to suitable habitat. Okay, almost in all the places in southern Western Ghats. Okay, the particular species is get reduced. Okay, or even if it is the worst case, okay, for RCP 8.5, okay, in the year of 2050, right, slightly compared with what I can say the 2.6, okay, to 8.5, even though slightly the suitability of very highly suitable habitat has got increased. So that's what it clearly is mentioned that. Okay, compared with it. And in the year 2070, the modeling, okay, in the case of RCP 2.6, it clearly indicates that the suitable habitat areas completely is shrinking over it. Okay, even for 8.5, also same thing. It has been we got the results. Okay, which indicates that in future, okay, there is a possibility of because already the species has become endangered. Okay, it may extend another 100 years or another 200 years, probably it may. So then you have to take care of it. Okay, you have to provide the adaptation or conservation strategies to preserve the particular species, and that's what we are doing it. Okay, the other species I would like to show you. Okay, the modeling, it is called Stabilanthus gundiniana. I think probably you might be knowing it. Okay, this is this flower. Okay, especially in Nilgiri Hills, okay, Kodaikanal and the Uti. Okay, in Tamil Nadu, you may see, okay, once in 12 years it blooms. Okay, it is called Gurunji flowers. Okay, so this also we have mapped. Okay, because we have collected some data, and based on that we have mapped. This is the Uti region, okay, Nilgiri area, and this is the Kodaikanal region, where you can find it. Okay, the current distribution clearly indicates that, okay, very high suitable area. Okay, these are the places, right, at current model what it says based on the data which we collected. But when we run the model, okay, in the 2.6, okay, in future 2050, right, in the Uti region, most of the what to say the area, the habitat is got decreased. Okay, and even the Kodaikanal region also, right, it is got decreased. When you use CP 4.5, okay, the representative concentration 4.5, in the year 2050, see the Uti region, right, is completely vanished. Okay, you may not find it, and also even the Kodaikanal region also, there is a decreasing. There is a huge amount of decreasing the habitat. And if it is RCP 8.5, you may not find a single species at Uti region, and also Kodaikanal region is going to come down. Okay, but that's in the case of 2070. Okay, and the RCP concentration 2.6. Okay, it is clearly indicates that the Uti region may disappear. Okay, so this is what we have been based on our modeling. It indicates. So what we have to do, certainly we may have to look for providing conservation strategies. Otherwise, our fourth generation may not witness the particular species. Okay, so certainly we may have to think of providing a particular strategy to conserve the species. Otherwise, what will happen? Because we all have witnessed the 5 mass extinctions, probably might be studied, right, from what to say the Ordovician to the Cretaceous and Cretaceous, okay, where the Jurassic Park has been completely vanished. Okay, so we already the Earth witnessed 5 mass extinctions. When you do not think of it, okay, when you start acting on it, certainly we are moving towards the 6th mass extinction. Okay, I think with this, I thank you the organizer for giving an opportunity to share the experience of it, and really I thank my research team Mukesh Lal Das, Swadisha Nawab, Shalu George, or Manjusha, Abhita Palachandran, and Ziveria. Okay, they were all worked hard to bring some of the data. So, okay, still the people are working on it, right? With this, I thank you. Thank you all for listening it. Okay.
Thank you so much, sir, for this wonderful session. Now, participants can post any of your doubts in comment section. Sir, we have few doubts with us.
Please,
First one is there any restricted species of animals and plants in Western Ghats?
restricted means, I'm sorry.
Like it is like they are present only in Western Ghats.
Yeah, yes, mental because that's what I said. There are 5,588 species only in endemic species. Okay, based on that only it has been classified as a hotspot, right? You may not find it
Okay, sir.
anywhere. Okay, it's endemic species.
Yes, sir. Sir, is there any species that can be used for climate change indication?
Indicators, what we can say, if coming under the category coming under vulnerable or endangered or critically endangered, extinct and wild, it indicates that it is because of climate change only. It's an indicator. It is an indicator because the particular habitat is going to lose. The species is going to lose in the earth. It indicates clearly.
Okay. Yes. Thank
That
you,
is
sir.
why
So there are few.
we are working with the endangered or critically endangered species to conserve, especially for the plant biodiversity. We are working on it.
Yes, sir. Thank you, sir. Sir, there is another question like, sir, is it MGET model is a useful modeling tool for predicting species richness or other predicting purposes?
No, it depends. It depends. There are many tools are available. Okay, but what we are using is a Maxent model for distribution. Okay, potential for studying this potential. We are using the Maxent model. There are many models are available. Many scientists are working on it. Okay, it depends on the output. Okay, any model, whatever the model use, depends on the area where it fit and how the outcome it come out. Accordingly, we can decide whether which one is good or bad.
Okay, thank you, sir. So, last question. Sir, what is your opinion about the environmental impact that could be caused by the purposed semi-high-speed rail project in Kerala?
No, it's a government project. Okay, we cannot comment anything on it. I'm sorry. Okay, it already has been approved, right? Because based on the how to say the impact assessment, okay, the expert appraiser committee has given positive, or we can say environmental clearance has been already they given. That is the reason they are starting. Okay, certainly any development there is a possibility of a loss of habitat or disturbance will be there. Okay, certainly will be
Yes,
there.
sir.
Yeah.
Okay, so one more question. It is like, can we implement nature-based solution for tackling the problems of climate change in Western Ghats?
Yes, surely, because that's what even the Paramikulam tiger reserve they're doing it. Okay, they're doing it. They are rejuvenating the forest, right? And they are identifying where the vulnerable areas. Okay, there they're developing on the forest cover. Likewise, we can do it. We can do it.
Okay, sir. Sir, like final question, sir. Sorry. Any
Yes.
paleo or neo-endemic species in Western Ghats, sir? Paleo or neo-endemic
No,
species?
as I said, according to the high-level committee has clearly mentioned that every year there are new species are inventing it. They're discovering the new species. Okay, we are not completely explored the Western Ghats, right? Because one of the reason it is highly protective area. You cannot go inside without permission. Even permission, if you give, you are getting the permission to visit the forest, you may not enter in the core forest area. So we may not know, we are not explored completely. That is why the high-level committee has clearly insisted that every year they are discovering one new species. Certainly, okay, if you
Okay,
explore,
sir.
you will get many species. Many species are available. Okay, The problem is, unfortunately, we are not allowed to go, but there is one way it is good. Okay, the diversity will be maintained.
Yes,
Otherwise,
sir.
we will destroy.
Thank you, sir. Now, as we have reached to the end of today's session, let's hear a vote of thanks from our program convener, Ms. Mahamadhu.
Good evening to all. On behalf of the ECOR family and all the participants present here, I would like to take this opportunity to convey my sincere thanks to Professor Dr. Muthukumar sir for sparing his precious time to give us such a wonderful compulsory talk. This highly informative talk has implied us with some new concepts which has to be taken into consideration while implementing our actions to reality for the protection of irreclaimable biological resources for the impact of climate change, from the impact of climate change. Here, I would like to pinpoint some of the notifiable points from the talk, such as importance of biodiversity, habitat loss, degradation and fragmentation, biodiversity hotspots criteria, hotspot endemism, history of Western Ghats, which highlights its site relevance. Western Ghats considers as the hottest hotspot in the world because of its wide range of forest range, plants and animal species, endemic, vulnerable and threatened species of plants and animals of Western Ghats. Maxent, ecological niche modeling tool to predict pattern changes in plant biodiversity to identify vulnerable areas, etc. Application of remote sensing tools, including the satellite imageries to study the changes in the biodiversity patterns, land cover changes, and the changes in the other environmental physical factors, mainly focusing in the temperature changes, and vegetation index tools such as NDVI and RVI for biomass estimation, land use cover change, crop plant estimation, etc. And other advantages of these remote sensing tools, and also finally the ecological modeling. So we all know that Western Ghats is famous for its climate-dependent or sensitive wildlife ecosystem. One of the reports in the Hindu News, backdated on 8 May 2020, briefly explained the impact of climate change on Western Ghats biodiversity, especially affecting small-bodied mammals, which are considered as the indicators of climate change and ecological system imbalance. The report also demonstrates that a huge extent of habitat space may change as unsuitable by the year 2070, which may cause the reduction in the population and even the extinction of these species. By taking the situation into account, I would like to convey an important message to you all that we, being the younger group of the society, it's our responsibility to be aware of, to make aware of, to participate and to take action towards any activity against the environment. The prior step to tackle with climate change should begin with regulating our own household activities. Start recycling the waste instead of burning. Use biofuels and renewable energy technologies and limit the over dependence on conventional energy resources. All these simple steps can definitely bring a huge change only if you are willing to do so. I hope this event has helped you to understand the dreadful effects of climate change on biodiversity and appropriate measures to be taken to reduce these impacts. Success of these events lies within your wholeheartedly participation and support. Once more, thank you, Professor Dr. Muthukumar sir, Dr. Amy ma'am, Director and Founder of ECOR, Mr. Jishnu PA, Program Chief Organizer, Mr. Sandeep PM, Program Coordinator, Ms. Malavika AS, and Ms. Lily Christie A, our society event partner, YOUNGO Foundation, and all other participants of today's webinar. Thank you.
Thank you. Thank you all.
Thank you, Maha Madam. On behalf of ECOR Foundation and the audience, I would like to express a word of gratitude to our esteemed speakers, Dr. Amy Lewis and Dr. Muthukumar sir, who has spared their valuable time and shared their extremely valuable talks and thoughts with us. It's a greatest privilege to have conducted this program as a side event with YOUNGO, the official youth constituency of United Nations Framework Convention on Climate Change. YOUNGO consists of youth-led organization groups, each focusing on specific aspects of climate change. We are also grateful to each and every one of you who have joined the webinar and listened to us with utmost patience. And also extend our gratitude to every single member of our technical team for all their efforts and support to make this webinar a success. Thank you all.